So the second claim I want to deal with is a claim that's been made that the hills around Bride are not high enough to be seen by from St Bees from the elevation that Anthony Riley was at. Now, as we've seen, Anthony took two videos. One was from around 80 feet or so above actual sea level, and the other was at around 120 feet above actual sea level. So from 80 feet above actual sea level, the refracted hidden height is 256 feet. Now, the hills around Bride are higher than that. Let's put in 256 feet here, or 256 feet, and let's convert that to meters. So 78 meters. So if there's anything above 78 meters, Anthony should have been able to see it in his first video shot from the lower elevation. Now, what I've done here is I've superimposed a Ordnance Survey map over Google Earth. And you can see that this is accurate because the roads line up perfectly. You can see that I've lit up the roads on Google Earth. So this is the A9, this yellow line, and this line here is I guess this A10 or whatever. And you can see that if I take the opacity of the overlay away, you can see that we have a perfect match between the roads and the on the Ordnance Survey map and the roads on Google Earth. So we know that this is accurate, and we have 80-meter contour lines in several places. I'll just take off these pins for a moment. So remember, anything above 78 meters ought to be visible. And we have 80-meter contour lines. There's a 96-meter high point here, trig point there. And all of these locations that I'm about to highlight are over 80 meters. Some are 90 plus, and all of these locations are over 80 meters according to Ordnance Survey map. And we should be able to see anything above 78 meters in Anthony's first video. His second video showed more of these hills in terms of their height, and his second video was shot from a height of 120 feet. And now we would expect everything above 195 feet to be visible, assuming a standard amount of atmospheric refraction, or a normal amount of atmospheric refraction, not exceptional atmospheric refraction, shall we say. So 195 feet translates to 59 meters. 60 meters, we'll say. 59 and bits. So 60 meters, we can say. And, oops, that's not where I want to go. I want to go back to Google Earth. And clearly, we have land all the way across here that is higher than that 60 meters. I suspect that actually we had less than normal atmospheric refraction on that particular day or at that particular time. And my reason for thinking that is this hill down here, which is marked at 68 meters on the Ordnance Survey map. And Anthony does not see this hill in his video. But I have seen this hill in video that I've shot, which you will see in later in this video or in another video. So clearly these hills are high enough to be seen in both of Anthony's videos. So this is the second claim that Anthony has made, that these hills are not high enough to be seen according to the standard curved earth model, and in fact we know that they are indeed definitely high enough to be seen, whether we have normal atmospheric refraction or no atmospheric refraction at all, or somewhere in between, which is in fact likely to be the case. His second video should definitely, you can definitely see a continuous piece of land where those hills are. Now, the next claim that I shall deal with is the claim that the distance between the leftmost point on the video, and which is the rightmost point on this map, because we're looking from this direction, and the rightmost point here on the photograph, leftmost point on the map, the claim is that this distance is not sufficient to account for the amount of land that we see. And that's the next point that I shall deal with.